So in this video we are going to see about another exercise. So this is very similar to the previous exercise, but here we are actually going to take the data from after putting in the Google Drive itself. So that is the only difference which we could see here. So the data set which we take here is the Twitter data set. So it is called sample.csv so you have Twitter ID, author ID, so whether it is inbound, created at text, and all those response and ID and in response to tweet and everything is actually given here. So that is what you are actually taking, and this is the program. So in this what we are basically doing is that the main thing which you have to understand here is that so you are importing all the required libraries. So once you have all imported all the required libraries, then you have to actually mount the drive in the collab. So why do we need this is that while doing this you will have to do a simple OK check with your corresponding email ID just for the verification and the permissions. And here see when you look at this one, say my data is basically here. So I have put in the collapse and sample. So when I right click here, I have this copy path, and this copy path is the path which I have actually used it here, right? So this is very, very important, because otherwise only when you will be able to put this path and access the data from within the drive, okay, because you have uploaded the data in the drive, okay, and only if you have mounted the data or mounted the drive in the collab, you will be able to access this particular data, otherwise you will not be. So this is actually the mounting. So you have actually mounted, because you can actually go here and access the data from the from within the collab itself, okay. So that is what we are actually calling it as mounting the data, okay. So this is very, very important. And the first one is nothing but we are just we are using a data frame. So data frame, so when we look at here, we have the Twitter ID and everything. So everything is actually taken it as a type as a string. And so as because we need to perform various string related functions as well. So that's why we are actually using it as this one. So now the next one is all about lower casing. Lower casing you already know. So we are just using the direct string str.lower function. So in that if you could see the capital A here, it is actually converted into smaller. So whichever capital letters are there, that will be actually converted into smaller letters, okay. And then removal of the punctuation. So in removal of the punctuations, these are all the various punctuations which will be removed. And so I mean, like in this exercise you could see that we are like progressively taking the output of the previous step and formulating it. So that's why we have this function called lambda function. So lambda function in Python are very, very important. So lambda functions are like the anonymous functions which can take a lot of arguments, and you can just keep on adding the arguments, and you can use it for whatever operations to be done. So if you don't want to name a particular function, and if you want to do something on your program, you can actually create the lambda functions, okay. So here when you look at this, this is actually a function which will actually remove punctuation is the function which will actually take a text, right? So the text which is actually taken is the text lower, which is nothing but this output, right? So that is actually passed, and you are actually doing a simple translation here, right? And when you look at here, you are actually doing that particular thing upon the text, and you are actually removing the remove punctuation of the text, right? So when you do that, you are getting the text without punctuation. So this is the output which you are getting, and the text, right? So you have the text dot, and you have also this what is that text without punctuation. So this is actually printed here with the help of this particular function. So you are applying that upon the text, and you are getting this, right? So that's the meaning of it. So you have this text, so this is your text, and you have this lambda function which apply this remove punctuation of text upon this particular text, and you will get this output which is actually saved in this text without punctuation, right? And the next one is stop words. You already know the stop words, we have already seen that. So you have actually imported it, and you have downloaded it. You are actually importing all this English ones, okay. And then you are actually using it. So in the same way, it's basically, so the output of the previous step you are actually taking, and in that you are actually removing all the stop words, right? So causing the is basically removed here, law A is actually removed here, all is actually removed here, so like that. So this is how actually this function will work. So if you look at here, okay, you have this text without punctuation, then you are actually applying the remove stopwords function upon it, and your result is basically stored in this one, right? And then comes the next one is basically the removal of the frequent words. So if you want to remove the frequent words, first thing is that you need to find out I mean, like, you are actually finding out the most common 10. Okay, so I mean, like, this is a simple function which will just count the number of the words, and it will just give you the count. Okay, so then comes again you are actually taking the without stop words, and then you are applying the remove frequent words upon it, and you are getting it. But this is actually a customized function which is actually written for removing the frequent words. It is not mandatory that you have to use the same function. You can actually create your own function and use it. So this function is up to you. You can actually write it in the way, and according to your application you can actually customize it, and you can write it, right? So here for each word it is actually taken, and in the text you are taking each word and you are actually making it into a split, and you are checking whether it is not in the frequent words, right? So because you have already got this frequent word list, so you are just checking whether it is not in there, and just making sure that it is not in there, and whatever is not in there will be actually put into this text without stop frequent words. That's all. And again you have something called removal of this rare words. So removal of this rare words is also very similar to the pre-processing, but here you will also remove the rare words from the corpus. That means that those words which are not used very frequently will also be removed, right? So here you are actually taking without punctuation, and you are actually dropping that first, and then you are actually the number of the rare words which you are going to take is actually 10 rare words, and this is actually a customized one which you have actually written, and this is also a customized function. So this part basically you can actually write it in the way you want. Okay, so it is not mandatory that you have to follow this one. So there is a small thing which you have followed, but it's not mandatory that you have to follow it. You can customize it according to your application. So here if you could see, you are actually taking those text without stop words, and then you are applying the remove rare words from that, right? So it's kind of a progressive step that we are actually following. So that's what I did. So here if you could see, say I'll show you. So in this example you are not able to see much difference, but still when you work on a real databases you will be able to see much differences based on that, right? So that is basically possible. And then comes the stemming. So understand there is a possibility that you could even remove because this removing the rare words will help you, because this will help you when you are actually when you are actually learning about the TF IDF. Okay, so because it's actually inverse term frequency, so when you are actually doing that, it will allow you to get a proper output. Okay, because inverse document frequency will pick up all the rare words and give it to you, and it is actually given much weightage, right? More weightage there. So but if you are actually removing it, unnecessary words are actually removed, then it will make your output more appropriate. Then comes about the stemming. Stemming you have already seen before. So this is actually the one which they are using here as a porter stemma. So again these are all customized ones. This you could actually apply it in the way you want. So here you could see that. So the reply is basically given it as reply. Okay, and say business is basically given it as busy, right? So this is not, but according to the porter stemma, yes, it is correct. Then you can also have snowball stemma, because you have the snowball stemma for all these languages, so you can actually try it out by yourself for that. And then comes the wordnet, because if you want to go for the lemmatization, because we are actually using the wordnet lemmatizer, so you can actually go for this one. So lemmatizer basically gives more importance to the context, right? So you have already seen that in the last session. So here we are using the wordnet lemmatizer, and here also you could say that it is actually taking the text and it's applying the lemmatized words of text on and you are getting the word lemmatized. So here you get a better reply. I mean, like in your stemmed output you have this reply, but here it basically gives you reply itself. And if you look at here, it is busy, but it is actually giving you business itself. So it makes more sense, because it takes the context out from it and it gives you more appropriate output. And also the other thing which you have to keep in mind is that, say if you're giving running, it is actually giving running itself, it's not giving run, right? But if you want to get it as a run, okay, then you can actually specifically give it as a verb, okay. That means that this for this running you need to find the lemma, which is a verb, right? This is so you are just informing the lematizer that this is a verb, so I want the stem for this particular word running, okay. So like that you can specifically mention. So when you look at here stripes, so if it is a verb you will get it as strip, and if it is a noun you will get it as stripe, right? And you can also use the average perceptron tagger. So that is for your because taggers are always will give you actually a hierarchical structure or a tree structure, and so this is your POS tagger. So your POS tagger means post your parts of speech tagger. So when you look at here, you could see that you are using your own way. You are actually taking this text and you are actually splitting it, right? And you are actually returning something. So when you return here, you could see that you're mentioning that I want it as a noun, so wordnet.noun has to be there. So when you look at here this third example, let's just go back to the third example. So here one second, just a second. So in this example you could see that, say Virgin Trains, right? So Virgin Trains is actually a noun, so the Virgin Trains, its name is actually kept as such, right? So this kind of things, if you want to specifically want something to be followed when you do a lemmatization process, then you could actually give that in your code itself. Then the other one is basically removing the emojis, okay. Removing the emojis, say this is like say if you have an emoji you can actually remove it. So the game is on and kind of hilarious, so this is actually removed. So how you have actually removed is you are actually specifically giving certain emoticons and its corresponding Unicode. So if you are giving this, it actually takes it and it actually removes it. So here it's just a regular expression which actually removes it, that's all, okay. And so this is just one example which this is from one of your one of the GitHub code which we have seen. So where we have actually taken, just a second, it's not moving, one second, yeah. So if you could see, this is a big one, this is a big data set of all the emojis, okay. So this is the emoticons in the sense like say in the while writing a text we give some. So this is an emoticon, so this is why this is an emoticon and this is an emoji. That's the difference between the emoticon and the emoji, okay. So you can also, so if you have a proper data set, or like a lexicon, so this is a proper lexicon which tells you about each of your, so if you see something like this means that it is surprised, right? So you should have a proper data set like that, then you can actually remove it, and or emoticons could be removed. So here if you could see, say hello and this one, and it is actually giving you a simple hello, right? And here I am sad and it's actually just giving, so it's removing all those emoticons as well, right? So that is actually possible. And then you can convert the emoticons into words, so that is also possible. Say I'm sad or happy face, so whatever be its corresponding name, that will be actually displayed back to you. So this is this we have already seen, so I'm just skipping this one because you can actually convert them into its corresponding it's a pretty big one, so I'm just taking it a bit faster. Now the next one is actually removal of the URLs. So URLs, the main thing is that you can actually give regular expressions. So whenever you see HTTPS, www. or something like that, you just remove it with a simple space. So that is what you are actually doing. So you could actually see all these examples here, right? So all these examples you are actually removing the URLs, and you can also remove the HTML tag. So you're actually, again for that, you are also giving a regular expression here. So whenever you see such a tag, you remove it and replace it with a space. So that's what you are actually giving. So you are actually giving a small example here. So it is actually removing everything and it's just giving you the content, right? So even the URLs are removed and you are just getting the content, right? So now another thing is that you can there is a beautiful There is a package called Beautiful Soup. So you can also use the Beautiful Soup package, I mean, like, to get the text from the HTML content, because normally in the bigger programs we basically use Beautiful Soup in order to extract the contents, right? So you are actually giving the text and, you know, XML format, you know, you will simply get the, you are actually using the remove HTML itself, but you will be getting, but you are actually, you know, in the remove HTML, what you are using is you are actually calling the Beautiful Soup, okay? So you are converting it into a text, right? So this is also possible. So this is one particular package which will help you, and you will see this very often when you actually start working with Python for web scraping and for getting the data from the websites and everything. Okay, Flask is another package and Beautiful Soup is another package. So Beautiful Soup is also very commonly used. And the other one is actually the chat words with conversion, right? You know, say you have all the short terms which you will be using nowadays, and like between BTW is like, you know, by the way, B4 is nothing but before. So there are almost, you know, a lot of words which we will use it like this. So we have to convert them into the exact meaning of it and make the people understand what it is. So you will actually go through each line by line and you will split them, you will expand them. So this is nothing but your chat words string split, and then you are actually, you know, setting all your chat list, and then you are actually doing the conversion here. So you are just appending, you know, whatever is there in that particular dictionary with the right words, and you are actually appending it. So say if you are actually giving like chat words conversion 1 minute BRB, right? So you will get its corresponding meaning. Okay, so I'll be right back or be right back, something like that. Okay. So this kind of things are basically possible. Another one is like your Grammarly, like your spelling correction. So spelling correction, for that, you know, you require a package. I mean, like, you need to install a particular package called PySpell Checker. So if you install that particular package, you could use that. You can import this from spell checker, import spell checker. You can import it, and then, you know, you have a function called correct spellings, and then you are actually putting the text inside, and the correct text is actually, you know, kept as empty. So this is where you will get all the corrected text, and the misspelled words will be, you know, you have to split all those things. Then for word by word you have to go and make sure that, you know, you need to go through the spell correction function, and you need to correct it, and you have to append it along with the words, and finally you will be putting that in the corrected text. So that's all. So spelling correcting. So if you are like spelling correcting, then, you know, you will be getting the right words here. So the spelling will be corrected like that. Okay. So then the next one is actually yes. So thanks for reading the notebook, and you are, you know, correcting it and you are getting it done. So these are all certain examples for text pre-processing. So this is really important. And so in text pre-processing, basically we have actually learned about so many methods. You know, the various pre-processing methods we have actually learned. So you can actually take some time and download this and put it in your Google Colab, and, you know, you can start working with this. So if you have any confusions or anything like that, you can get back to me, and always understand that the methods for the functions which you have done, you know, you don't have to I mean, like, you know, you don't have to do things by the scratch. If you want to do things from the scratch, it's always well and good, it's fine. But otherwise, you know, you have all the resources in the world and it's available, so better make use of it and make your life easy, and try to tweak it in the way you want. So that is one talent which you have to learn. So tweak it in the way you want, and, you know, use it for your application. So all the best. If you have any doubts or anything like that, you can always get back to me. Thank you so much. Hello all, in this video we are just going to see a small program which will help you to understand about the term frequency. And the term frequency is actually calculated by using the frequency distributions function. And what a frequency distribution function does is that it records the number of the times, okay, it records the number of the times each outcome of an experiment has occurred. Okay, so a frequency distribution could be used to record the frequency of each word type, okay, in a document. And frequency distribution can be defined as a function mapping from each sample to the number of the times that occurred. So basically it helps you to identify the frequency of the terms in a record, right? So that's what. So but you have to think it as a probabilistic distribution, right? So when you look at the import, I mean, like, all the packages to be imported, you need to have NLTK package, and you are actually importing this frequency distribution from NLTK.probability. Okay, so this is very important. And then comes you are actually including the stop words as well, and you are downloading all the stop words. So this all these things you already know, and you are actually setting all the stop words to stop underscore words, right? So this is what you have done. And then you are actually using the Gutenberg corpus here. So this is a corpus which has got almost like 2500 free electronic books. Okay, so this is what it has got. So this is actually throwing you error because you have not run the file in the order. Okay, because when it is actually running, it is actually showing you error because it cannot find the stop words, right? So now you are actually downloading the Gutenberg. So once you download the Gutenberg, and then you can also so this just shows you that the file IDs, which all are the different books which you have. So it just shows you the initial few, and then you are actually reading the Brian. So this one, so Brian stories.txt. So from this you are actually taking the words, right? So this is the storybook that you are actually taking, and then you are actually doing a little bit of pre-processing here, and after that you are actually coming back to the frequency distribution. So it records, as you know, it records a number of the times each outcome of the experiment has occurred. So this is exactly what we have actually learned. So say if you have cat, dog, fish, everything, then we can actually categorize them as cat, dog and fish, and the dog is 2 and the cat is 3 and the fish is 1. So this will be actually given to you, that's all. So here what you are basically doing is that you are actually finding the frequency distribution of the words. So this is how you will actually call this particular function, and when you look at the length of the words in that particular whole thing, Brian stories, you could see that this much. Then you are actually making it as different sets, because here we need to make it as different sets. So you are making it as different sets, then you could see that almost 3688. And frequency distribution so works like a dictionary, right? So dictionary with the keys as the words in the text, and the values are nothing but the count. So it looks like a key value pair. So when you look at here, so you are actually traversing through the DIST, and you are actually taking the first 10 words in that, and displaying both the word and its corresponding count. Okay, that is what actually you are doing. So when you look at it, you will get the word and the count. Say now if you want to find out the probability of it, then you can also do that by using this particular formula. So if you want to know the probability distribution itself, you can actually come out with the formula of this xv, and what is the v? It's your count divided by the length of the f distribution. So you will get the probability. So this is how it works. So this is how actually you could find out one of the ways for finding out the term frequency. So this term frequency also will help you in the feature extraction, or for identifying the major words or the topics from within your main content, right? And then comes the TF IDF. So we'll see few examples for identifying the TF IDF. So here we are actually importing the NLTK package, and after that we have just taken some lines of code from Bahrain 2030 Vision website. Okay, and so these are the codes which we are actually like the text that we are actually going to work upon, and then we are going to clean a little bit. So cleaning, we need definitely the regular expressions. By this time we already know, and the stop words we require, and we need a stemmer and a lematizer. And for that, for the stemmer we are taking the Potter stemmer, and for the lematizer we are actually taking WordNet lematizer. And then we are actually downloading the Punket. Punket is basically made to learn the parameters in the corpus, and that will be learned in an unsupervised way. So say such as list of abbreviations, acronyms, etc. So that's why we require that, and we have downloaded the stop words, and we know the WordNet as well. So WordNet is actually kind of a lexicon where it contains all the words and its associated words, and everything will be there, right? And we have actually downloaded the WordNet also, and then we have this Potter stemmer, and the pre-processing is basically done. So we are using a simple regular expression. So in this regular expression, basically it will match all those uppercase letters or lowercase letters and it will also identify the, I mean, like A to Z means it will try to understand everything between A to Z, right? And it will negate all the following characters, and then we are actually doing the pre-processing of lowering the capitals into small letters, and then we are splitting the sentences, then we are applying the lemmatization, right, and then appending the space in between the results. So this is what actually we are aiming at for the pre-processing part. So exactly this is what we have actually done here. So we have actually taken the paragraph as the sentences, and this is our stemma, and this is our lemmatizer, and this is the corpus is initially empty because this is where we are going to plan our sentences in the final result, and we will go through the length of each sentences, then we will do the we will apply the regular expressions, then the lower, the split, lemmatization, then we are actually joining the results with the, and then we are actually finally appending it to the corpus, which is initially empty, right? So it's very easy for you to understand. So if you are looking at the first sentence in your, or first one in your corpus, you will get this launch vision, so blah blah blah, it's just taken everything and stopword is removed and everything, and this is the first one which you will get. So now when you have to calculate the TF IDF, so the best way of calculating and understanding about the TF IDF, I always feel that, you know, the Wikipedia definition is the best one for us to understand about the TF IDF. So for understanding the TF IDF, TF IDF is nothing but, you know, TF into IDF. So we need to know how to calculate TF. We need to know how to calculate IDF. Then we need to have then you should multiply TF and IDF, right, values. That's how it works. So when you look at the term frequency, as you all know that, you know, how many times the frequency of the term T within the document. So its formula is as simple as its simple ratio. It's a simple probabilistic function. So TF IDF of T is this your term, and upon the document, so you have the frequency of the T comma D divided by the sum of all the, you know, frequency of term. So this is how it is. So it's very simple for you to understand. And then you have to also understand about the inverse document frequency. So why we go for this inverse document frequency is that, you know, we need to give weightages for those rare terms which is across the documents. So it is logarithmically scaled inverse fraction of the documents that contain the word which is the rare word. So it's a measure of how much information the word provides. So understand that inverse document frequency will give you the amount of the it will help you to understand the kind of the information, specific information that each word is actually providing to you, which is spread across the documents. So sometimes some of the words like the occurs many number of times. So when you take the inverse frequency, it's actually you're taking the logarithm of it, so you will get a lesser meaning. So that means that the doesn't provide much of information for you, right? But say just you have a rare word called called artificial intelligence across the documents, but you will understand that artificial intelligence, that term actually brings you a lot of information than the word which is the, right? So this is why we basically go for this inverse document frequency. So in inverse document frequency, you are actually taking the logarithm of n divided by the document and T, which is element of D, right? So this is how actually you are doing. So it's an inverse document frequency. So this is how n is the total number of the documents, and this is the number of the documents which is containing the term T, right? So if the term is not in the corpus, right, so this will lead to a division by 0. So normally, so we will have this definition in such a way that log n divided by 1 plus, so that, you know, it is doesn't end up with something like division by 0 error, right? So this is nothing but inverse document frequency. Now the final formula is very easy. So we know how to calculate TF of TD and IDF of TD, then you have to simply multiply them, right? So the beauty of the in order for you to understand or to know the beauty of this definition, so a high weight in TF IDF, say if you get a high weight in TF IDF, okay, so that means that a high term frequency in the given document and a low document frequency of the term in the whole collection of documents, the weight hence tend to filter out the common terms. So it will actually filter out all the common terms because you have high frequency for the word, but you will get a lower value here, so it will balance it out, right? So since the ratio inside the IDF log function is also equal to 1 and the IDF is also equal to 1, your whole values will be within this 0 to 1. So there is a small example actually which is given again in the Wikipedia, which I always feel like is the one of the best examples. So there are two different sentences, which is actually two different documents in fact. So the documents has got the sentences like, you know, this is a sample, this is another sample, and it's corresponding the term count. So the term frequency is also given. So if you want to find out the term frequency, it is very simple. So the term frequency, the formula is basically this is the formula. So the frequency of t over t divided by the sum, right, of all of them. So when you look at here, say if you want to find out this, okay, that TF IDF for this, then what you have to do? So it's very simple. So always understand that when you find out the TF IDF, the TF IDF will be worked out for a particular term in a document, okay, upon a document. So this is how you will work out. So say you are working, you are finding for this. So it is actually 1 divided by 1 plus 1, 2 plus 2, 4 plus 1, 5. So this is the total number of count. So 1 by 5, right. So again in this particular document, if you see 1 plus 1, 2 plus 2, 4 plus 3, 7. So the total is 7, and the count for this is basically 1, right. So 1 by 7. So you got this count, I mean like the term frequency count. And now you need to find out the IDF. So IDF is basically here. So when you look at the IDF, it is n is the total number of the documents. So it is 2 divided by this one. So t, the number of the documents were the term t, right. So when you look at here for the this IDF of this and d, it is like 2, and this occurs, right, number of the documents where this occurs. So there are two different documents, in both of the documents this occurs. So 2, right. So 2 divided by 2, so log of 2 divided by 2 is 0. So when you calculate this, what happens is that, you know, both of them, you know, imply it's to 0. So that means that the word is not very informative because it is not closer to 1, it is actually closer to 0, right. And again when you look at another maybe, you know, another example like example itself. So when you look at it, so 0 by 5, right, 0 by 5 is say the example is not available in the first document itself. So 0 by total count is 5, so 0 by 5 is 0, and here it is actually 3 by 7, right. So 3 by 7 you will get it. And then IDF is example. So what you could do is that you have two different documents. So n is capital N is the number of the documents. So 2 divided by this example appearing in how many documents, right, that's a denominator. So example is actually occurring in one of the documents, so 2 by 1, right. So in only one of the documents it occurs, right. So when you find out the TF IDF of example upon D1, so upon D1 it is 0, but upon the second document it is basically, you know, it is giving you some particular value. So you are getting some value which is actually closer to I mean like it is 0.1. So it is actually somewhat it is relevant to. So when it comes to, so this is how you will understand that it is 0. So that means it is this example, the word example is not relevant to the first document itself, and this is the probability, or this is the percentage that at which, you know, this particular word is actually relative to the second document. So this is how it will help you to identify the TF IDF, right. So now coming back to the you know, to how we can actually use this and apply this in the TF IDF model. The first one is that, you know, we need to create a TF IDF model. So for creating the TF IDF model, you know, we are basically using the sklearn package. So from the sklearn library, you are actually, you know, taking, so in sklearn you have this TF IDF as vectorizer. Actually that is there in the feature extraction.txt. That means you have functions which are packages for feature extraction and explicitly for the text you have, and in that there is a function called TF IDF vectorizer. So we are going to use that particular function. So CV is equal to TF IDF vectorizer. So x is equal to cv dot fit transform of corpus. So I mean like we are going to apply this corpus upon this fit transform. So we need to know what is actually this fit transform. So it is used on the training data. So always understand the fit transform is used on the training data so that we can scale the training data and also learn the scaling parameters, right. So hence the model built, okay. So hence the model built by us will learn the mean and the variance of the features of the training set, and the learned parameters are then used to scale out the data. So this kind of a, I mean like transformation means this kind of a normalization which we will do upon the data, and then you are actually making this output to be represented in the form of an array by using the toArray function, right. So if you look at the array and you are printing the x is nothing but the final results will be there in the x, right. So when you look at it, you could identify that, you know, you have got the terms, I mean like you have got certain values, right? So 0 dot and all this values. So this values basically will help you to identify that. Say we are actually taking the corpus, right? So in the corpus you will understand that, so the first term, whatever be the first term, that term is basically relevant to your document, and this one is also relevant. I mean like say this is not that relevant, so this value is not relevant, this value is not relevant. So like that you will be able to identify which of the terms are basically relevant to your document or not, right? So this is how you will actually work on this, right? So another simple example, I wanted to say the same example which we have actually seen in the Wikipedia. This is what it is. So I'm just putting it as a document, I'm just putting it as a paragraph, and then applying all the pre-processing that we have done. So we have sample, another, all those the etc is actually gone, and another sample, and you are actually doing it. So when you look at it, so you have sample and you have another sample, right? So it just gives you, like in the first document it is not having that much of so sample is there in the first document, so it just gives you like it is relevant, but in the another sample is actually relevant in only this much relevant in this document. So that's all which you will be. Now if you want to give exactly like two different document A, document B, that is also possible. There is a function called bag of words where what you will do is that you can use a simple split function, and you will be splitting this whole document with the help of this separation. So separation actually here is actually the space, and you are actually taking it as bag of words A and bag of words B, and we will learn about bag of words in the next coming sessions in detail. When you learn about the word embeddings, you will learn about bag of words and skip gram models in a detailed way, right? So you're actually making it as a set of bag of words A and a set of like you're categorizing it, and you're putting it as unique words, and you are finding the number of the words. So it's just a number of the words, and you are actually getting the keys, and you are going through each and every one, and you are actually counting each words in the number of the words, right? For A and B you are actually counting, then you are actually using the stop words, and you are computing the. So here what you have done is that you have actually coming out with a function called compute TF, where you will pass the dictionary and the bag of the words, and here you will compute the whole. So this is your normal function which you have seen, but we have actually come out with the function itself, that's all. So you are basically doing the TF IDF TF dictionary count is nothing but count divided by the float, right? I mean the values, and so you got the TF A and TF B, and then you are actually again coming out with a function for compute IDF. So compute IDF, you are using the IDF dictionary, so again you are actually computing the IDF first, right? So this is a function which will help you to return the IDF. So here basically when you look at it, it's your log of n divided by the number of the documents, right? So it's the same thing, but you have actually made it as a function, that's all. So you are actually passing it out and you are getting it. Now you are actually computing your TF IDF. So in TF IDF basically you are actually taking the value into, so here it's a value, right? The value into the TF IDF words, right? So IDF word is what is actually returned. So that will actually give you a TF IDF, right? So when you compute this, finally, when you compute this, you will get the same thing. So this is this another sample is so this is actually, so for the document 1, how is it actually relevant? For the document 2, how is it actually relevant, right? So this is how you will actually get it. Now we were also talking about the TF IDF vectorizer. So TF IDF vectorizer will convert the values into vector format. Okay, so here actually you can, instead of the corpus, you can actually, the fit transform of corpus, we have already used it in the previous example, right? Instead of that, you can also give all the documents individually, that is also possible. And this function has changed from the, like now it is actually giving get dot features names out. So this is the feature names, and then you are actually making it into a dense vector. So this is a vectorization step, and then actually you are making it into a list, and then you are actually putting it into a panda frame data. Okay, so when you look at it, the data frame will always work in the form of an array. So if you could see that, how each one is basically giving you and giving you about the how each element is actually relevant to each document, you will be able to identify from that. So the main idea behind the TF IDF is that. So this shows that in the above example, so the word another doesn't appear in the document 1 at all, and it is totally irrelevant. So that's what actually it is here. So as the value is 0, right? So this is how you have to understand about TF IDF. So hope you got an idea about what is TF IDF, and this is the way they will extract the details from the documents. Okay, so let's see on another video. So if you have any doubts or anything like that, always get back to me. Thank you so much.